Hello friends, welcome back to TRB-2023 series. So in this session, we are going to start the next chapter, that is Z transform. As we already discussed in the last class, we have completed Fourier series, Fourier transform, continuous time Fourier transform, discrete time Fourier transform. So we have completed all the basics, important things and formulas, everything. Now in this session, we are going to start the another most important chapter, that is called Z transform. I told you we have to cover Z transform first. After that, we are going to start sampling theorem. So first, let us finish Z transform. After completing Z transform, we will going to start sampling theorem. Then we will discuss about basics. Okay, chalo. So in Z transform, what are the basic things that you must understand? The first thing is recollect the formula. In Z transform, what is the general formula to convert any values from time domain to discrete domain? That is the first thing that you must keep it in your mind. Suppose if I have a signal in discrete domain is defined as x of n. How should I convert it into frequency domain? And the representation of any values in frequency domain is x of z. Here, the value of the z can be written as r into e power j times of omega. That is equivalent value of z. So we can write it as r into e power j omega, where r is the distance from the origin in z plane. Or we can say simply radius of the circle in z plane. R indicates the radius of the circle that we are going to draw in z plane. This is radius of the circle that we are going to draw in z plane. That is the meaning of R. Since in Z transform, we are trying to maintain the value of R equal to 1 such that R equal to 1 is the point at which we are trying to bring the stability of any system. Later, we will conclude these things further. So let us continue with this basics. Now, what is the formula, sir? How should I convert? If you want to convert any value from n domain to z domain, the formula is, there are two types of way we can define this formula. One is called bilateral transformation and another one is called unilateral transformation. Suppose if a sequence is running from n equal to minus infinity to plus infinity, then that is called bilateral transform. Since we are running from minus infinity to plus infinity into, we can write it as x of n into z power minus n. This is one way. This is called bilateral transform. And the second one is unilateral transform. Unilateral means your sequence is running either from minus infinity to 0 or from 0 to infinity. So what we can say is, you can consider either from 0 to infinity along with your signal is x of n into z power minus n, or it can also be redefined as, just recollect everything. You can also run from n equal to minus infinity to 0 x of n into z power minus n. So while discussing about unilateral transform, we are allowed only to discuss on any one side of this sequence. That's it, sir. That is all about unilateral. Next, immediately let us discuss about inverse Z transform. We are in Z transform. So this is how we are utilizing a formula to convert a signal from n domain to Z domain. Suppose I am having something in Z domain. I would like to convert it into n domain. That is called inverse Z transform. We are calling it as inverse Z transform. What is the formula, sir? In order to obtain the equivalent value in n domain, the correspondent formula is 1 upon 2 pi, as a same formula. So here we will be following a closed circle. We are always forming a circle in Z transform. We will come to know. Hope many of you might be discussed about these things, studied about these things. X of Z into Z power minus n. With respect to dz, we will have to complete this Z transform when we are in, 1 second, there is a small thing. While going in discrete domain, we will have to change this sequence to n minus 1. Yeah. So the formula will become 1 by 2 pi integral of x of z into z power n minus 1 into dz. Actually, in problems while solving, we are not using this formula. We are trying to directly, because what will happen is, When the moment I am having some signal in Z domain, and if you are trying to convert it into S domain by using this formula, it is really complicated task. Because of this, we will be following some other approaches. We will have partial fraction and other things at all in order to transform it. Because of that reason, we will not be using this formula often. So most of you have failed to study these things. Directly, if it is asked in one more question in the exam, that time what you'll be thinking, you may not be able to give the answer correctly. So it is very important to at least remember the formula. How to convert a signal from Z domain to N domain. What is the formula, sir? 1 by 2 by close the integral of x of z into z power n minus 1 into dz. That is very, very important. You must keep it in your mind. Hope you understand. Next, is there any condition? As usual, we are discussing from the Fourier series. While discussing about each and every series and transform, I was giving some conditions, some sufficient conditions. Of course, it is absolutely required. Without that condition, we may not be able to apply Z transform for all type of signal. While applying Z transform, your signal should get converged. Suppose if I am taking any sequence in Z transform, for example, I am having a signal and you are continuously summing up the signal. It should be absolutely summable. The signal should be absolutely summable for the overall range of n equal to minus infinity to plus infinity. Resultant value must be less than infinity. That is the sufficient condition to apply Z transform. You must remember, because if your sequence is not converges, if it is converges means your value should be less than infinity. Divergence means it is approaching to infinity. If your signal is divergence, then you may not be able to apply Z transform. In order to apply Z transform, it is very important that the necessary condition, sufficient condition is summation of summable. Your signal should be summable. The resultant addition of the total sequence from minus infinity to plus infinity should be finite. It should not be infinite. That is very, 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 very important point that you must keep it in your mind whenever you are discussing with the Z transform. Right? Now, let us see. I will be taking some basic signals and I will be showing you how to apply Z transform. Hope you all know, but I am just refreshing it once. We are having so many signals. Let us take some example. For an example, it is given that the value of x of n equal to del of n. It is given that the value of x of n equal to del of n. We all know del of n is a simple impulse signal. If it is the simple signal, then what will happen? Let us see. If you are applying it into Z transform, the value of x of z will be equal to summation n equal to minus infinity to plus infinity. X of n will be replaced by del of n into z power minus n. This is the formula. But we have a specific property for impulse signal. I don't know how many of you remember this. What is the specific property? If del of n will be multiplied with the x of n, if it is in multiplication, then the resultant value, what you have to write, sir? This function will be rewritten as del of n into, what is the position of x of n? X of n will exist at the position of del. See, since this del of n means the function is existing at n equal to 0. If del of n minus 1 is given, then the meaning is this function will be existing at n equal to 1. Since del of n means this function is lies at n equal to 0. So this can be written as del of n into x of 0 only. So this entire property will be vanished. This entire sequence. So this total signal will going to be lies at only one point, that is at n equal to 0. So what is the value at n equal to 0? That is what is we are going to conclude. So del of n into whole value. N will be replaced by strictly only one value, that is 0. So what will be getting, sir? Del of n into z power minus 0. Sorry, z power 0. What will be its value? This value will become 1 in the throughout integral. Total summation n equal to minus infinity to plus infinity. So if you are adding this net value, the resultant value will become 1 simply. Summation of del of n, the total unit area. Summation means in discrete domain, summation of del of n from minus infinity to plus infinity means in discrete domain this net value will be equal to 1. That is area of impulse function. What I can say, area of the impulse function, summation of the total value will be equal to 1. So what is the conclusion? If we are having impulse function, its correspondent Z transform is going to be 1. Just remember, that is enough. Del of n, its correspondent Z transform is going to be 1. In this similar fashion, suppose if you are having a signal u of n, How should I find the Z transform? Let us see. I will be taking one more example. X of Z equal to summation n equal to, write down the formula, register it in your mind, n equal to minus infinity to plus infinity. What we have here, the formula is x of n into z power n, z power minus n is what we are having. Now what I am going to do is summation n equal to minus infinity to plus infinity. In place of x of n, we are going to consider step signal u of n into z power minus n. We all very well know the value of u of n is going to be, this value is going to be 1, where the value of n is greater than or equal to 0. It will be 0 elsewhere. In rest of all zone, it will be 0. So what is the conclusion here is this function can be rewritten as n equal to 0 to infinity. U of n value is going to be 1 where into z power minus n. Now you can substitute n equal to 0, n equal to 1, n equal to 2, n equal to 3 and so on. If you are putting that, what you will be getting z power 0, z power minus 0 will become z power 0, then z power minus 1, then z power minus 2, then z power minus 3, then z power minus 4 and so on. Now if you are observing this function carefully, this can be rewritten as, how will I rewrite this function, sir? Let me rewrite. So this above function can be written as 1 plus x power, see, I am just considering the value of x is x power minus 1, okay, just x power minus 1, just to keep like this, x power 1 plus, so x power minus 1 whole power 2, x power minus 1 whole power 2 plus x power minus 1 whole power 3 and so on. That is 1 plus x square plus x cube plus and so on. What is the formula, sir? The formula is going to be 1 minus x whole inverse is the formula. In place of x, we have x power minus 1. But in our question, we have in place of x, we have z power minus 1 whole power minus 1. This can be written as 1 upon 1 minus z power minus 1, or else it can be written as z upon z minus 1. This is how we are applying Z transform for any sequence that will be given. Hope you all know it. So just we are refreshing once because it is completely revision class. I may not be able to explain each and everything here properly. All you have to do is remembering the basics is very, very important. Fine, sir. Now let us conclude. The conclusion from the above derivations are, first thing, if I will have an impulse function del of n, its correspondent Z transform is going to be simply 1. If I will have a step function u of n simply, then its correspondent Z transform is going to be Z upon Z minus 1. Or else you can say 1 upon 1 minus Z power minus 1, whatever it is. And the another most important thing is ROC, region of convergence. So what will be the region of convergence for the given function? The region of convergence is mod of Z should be greater than 1. That is the region of convergence for the given function. It means if you are drawing a circle for the given function, how will you draw the ROC, sir? In Z transform, ROC means we must form circle. We must form circle. See there, here we have 1. Correct, na, sir? Here we have 1. So we have to draw here. From the origin, radius of the circle will become 1. So draw the circle like that. After that, so from 1, this is going to be 1. Yes, everywhere it is 1. First, we should draw a unity circle from origin. After that, ROC will exist above the unity circle. So ROC greater than 1. Why, sir? Why it is above unity circle? Because we know u of n is a right-sided sequence. U of n is the signal which will be running from 0 to infinity. If any signal is running from right hand side, then that signal is called right side. Its correspondent ROC will be above the given point. What is the given value here? Z equal to 1. So mod Z should be greater than 1. Unity circle. The ROC, region of convergence, should be greater than 1. That is what we draw. This is region of convergence, ROC, for the given function. There is one more sequence, that is u of minus n minus 1. This is left hand side sequence. What will be the Z transform for this? You will be getting, you have to put minus here, minus of u of minus n minus 1, such that here you will be getting same answer, Z by Z minus 1. What about its ROC, sir? Both will give the same answer. Yes, see there, both will give the same answer. But what thing will differ here is region of convergence should be differ. Mod Z value should be less than 1 for this. If you are drawing region of convergence for this as usual, mod z should be less than 1 means this is 1. So less than 1 means inside the unity circle, this entire region will become the ROC for the second sequence. Second sequence is minus u of minus n minus 1. This is the ROC for that. The above one is, this is for u of n, this is the region of convergence. Hope you understand what I am trying to conclude. Now, let me take one more example for your better understanding. So, whenever right-sided sequence will be given, for an example, if it is given that a power n into u of n, then if you are trying to find out its correspondent Z transform, this is going to be Z upon Z minus a, or else it can also be written as 1 upon 1 minus a into Z power minus 1. Both are correct. But if you are observing the given function, sir, u of n, the given value has been multiplied by u of n. U of n is a right-sided sequence. U of n is a right-sided sequence. Right-sided means the region of convergence, mod z should be greater than a. Whatever the value that you have, it should be greater than that particular point. If you are drawing the ROC for this signal as usual, if you are drawing ROC for that, first take ROC. Take x and y axis. After that, we must draw the circle. What will be the value of the circle? See, the circle from the origin, the radius of the circle is a. Now, with the radius of a, we have to draw a circle from the origin. After that, you can say that greater than a. Where the value of mod is greater than a? This zone. This is radius of the circle is a. Above a, all the zone is called, will be all the zone will be considered as the region of convergence. So this point will be treated as, one second. Yeah. So this is point A. Sorry. Okay. This is point A. From here, above all these points are, all the zone is called region of convergence. So mod Z must be greater than A. That's it. Finish. Suppose if this same sequence, if it is given that minus a power n into u of minus n minus 1, then what will be the region of convergence? Sir, your answer will be same. What answer? Its correspondent Z transform will be Z by Z minus a, undoubtedly. Or else the alternative way of writing this Z transform is 1 upon 1 minus a into Z power minus 1. But its region of convergence, mod Z will become less than a. That is the most important point that you must observe here. So here this zone will be your region of convergence. It is less than a. So this is right side. Above a is called right sided sequence. Below a is called left sided sequence. This is how we are framing ROC, region of convergence. It is very simple, sir. Whenever it is given in the question, they will give only two type of ROC they will ask you. Always remember, it is very easy. Now, let us conclude. Simply, I will write, for an example, if I have 2 power n into u of n, what will be the ROC for this? If they are asking, find the region of convergence for the given sequence. One step directly, what you can say is, mod Z. If it is the right-sided sequence, then whatever the value that you are having, just to put greater than 2. That's it. That is the region of convergence. Done. Suppose if it is given minus 2 power n into u of minus n minus 1. They will define only in this way. Trust me. So the region of convergence will become simply mod Z will become simply less than 2. See, it is left-sided sequence. So the region of convergence, mod Z value will become less than 2. That is ROC. Suppose if it is given, let us assume that I have two functions now. One is 2 power n into u of n minus, it is given that we are also having 3 power n into u of minus n minus 1. Then what will be the region of convergence for this? It is very simple, sir. What we can say is, we know for the first one, the region of convergence should be mod z should be greater than 2. Why? Because it is right-sided sequence. For the second one, the region of convergence mod z should be less than 3. And remember one more thing, sometimes in the power, if it is always plus n, this value should be always plus n. Suppose if it is given like this, 3 power minus n into u of minus n minus 1, then what you have to do is nothing, it's a simple work. 3 power minus n, write down like this, whole power n. This can be written as 1 by 3 whole power n, that's it, see that? Now instead of taking 3, you have to take 1 by 3 if minus will be given. Fine, sir. Now, if you are drawing the ROC for the first function, see, let me club the ROC together. For the first one, the region of convergence should be greater than 2. For the second one, the region of convergence should be less than 3. So, the complete ROC is going to be common ROC. Now, you have to choose the common region for both of these people. First person is standing at 2, second person value is less than 3. Less than 3 means you will have to consider the total portion. Mod z less than 3 because this is left-sided sequence. Whereas mod z greater than 2 means how will you draw? Mod z greater than 2 means I will have to consider all the above region like this. If it is greater than 2, then you must consider the entire zone. Above greater than 2, you will have to consider the whole values. Now, out of this whole region, you will have to, what will be your resultant ROC? The resultant ROC will be the common zone between 2 and 3. What is the common zone? One is going downside, another one is going upside. So, they both are meeting between 2 and 3. So, the ROC, the resultant ROC must be lies between 2 to 3. The resultant ROC must be lies between 2 to 3. This is one conclusion. Now, for the same question, if it is given like this, wait. For the same above question, suppose they have given 3 power n into u of n is given, minus 2 power n into u of minus n minus 1 is given. Then what will be the ROC, sir? Here is the problem. Let's see. This can be written as mod z should be greater than C3, that is the region of convergence. For the second one, mod z should be less than 2 because this is left-sided sequence. If I am trying to draw the ROC for this function, if you are trying to draw the ROC, for the first one, the ROC is going to be less than 2. For the second one, the ROC is going to be greater than 3. How will you draw this? I will show you. So, the first one will going to be having the ROC inside this region. Only this one is going to be the ROC for the first person. Whereas for the second person, the ROC is going to be, the second person will lies outside this because mod z is greater than 3. Now the problem is, whenever you are having more than one ROC, you must have common region. You must have common region. If there will be no common region, see there ROC, this one is traveling greater than 3, this one is traveling with a less than 2. Such a kind of sequence are never ever allowed in Z transform. So your answer will be, for the given function, there is no common ROC. If there will be no common ROC, then Z transform does not exist for the given function. That's it. The correct answer is the Z transform does not exist for the given function. There is no common ROC. So definitely there will be 4 options. Out of 4 options, 1 option will be this one. Or else they will put none of the above. Like option A, they will say mod Z greater than 3. Option B, they will say mod Z less than 2. Option C, they will define it will be lies between 2 to 3. Option D, they will put none of the above, or they will put Z transform does not exist. So that will be your answer when there will be no common ROC, when we are having more than one sequence. So it is very important to remember these basics. Okay, hope you will not miss these things. Very, very important. Next thing. So I will take one more example for a better understanding. Okay. Suppose it is given that I will have 2 power n into u of n. This is one sequence. And the another one, what they told is, let us consider 2 power minus n. Okay, so 2 power minus n into u of n is what they give. So here what they put is 3 power minus n into u of minus n minus 1. Now, what will be the ROC? Whether the ROC will exist for this or not? Let us see. If you are observing, the first one can be rewritten as 1 by 2 whole power n into u of n. Correct, now, sir? Second one can be rewritten as 1 by 3 whole power n into u of minus n minus 1. From this, what I can say, the first one is having mod z value should be greater than 1 by 2 or 0.5. The second one is going to be mod z value should be less than 1 by 3. ROC will exist or not for this? So I can say that what we can conclude here is definitely Z transform does not exist for this. Why, sir? What is the problem? If you are drawing the ROC for this, there is no common ROC. Up to my observation, one function, the right side sequence is from 0.5. Left side is from 0.3. 1 by 3 means 0.3, na, sir? See, 1 by 3 means it should be 0.3. So if you are observing the left side sequence, 1 second. 1 by 3 means what, sir? 1 by 3 equal to 0.33. 1 by 2 means 0.5. So 1 by 2 is greater than 1 by 3. So I can say this is right side sequence. This is right side sequence. Whereas 1 by 3 is the left side sequence. That is here. There is no common ROC. So your answer is Z transform does not exist for the given. That's it. Z transform does not exist. Okay. So that is how to define the stability of a system. Sorry, the Z transform will ROC, region of convergence of a system. Next, let us come to the stability point. So the another most important point from ROC is how to define the stability. These are all basic informations. Stability means, always remember, whenever we are discussing about Z transform, in Z transform, stability means your mind should focus on unity circle. Only one thing should be there in your mind. Unity circle. What is the meaning of unity circle, sir? If the unity circle lies inside the region of convergence, if unity circle lies inside ROC, if the unity circle lies inside the ROC, inside the region of convergence, then the system will be stable. Otherwise, your system will be unstable. That's it. So all you have to remember is whether the unity circle, you have to focus whether the unity circle lies inside the ROC or not. If it is lies inside the ROC, then you can be very happy. If it is not, then you can say that the system will be unstable. Absolutely, it is not a stable system. So what they will give? They will give some different types of systems just to draw the ROC. For an example, if I am taking 2 power n into u of n, the same one, minus, let us say, given it is 5 power n into u of minus n minus 1. Now the question is, if they are asking you whether the system is a once again, take 2 power minus n, whether the system is a stable system or not, whether the given function. What you have to do? Just to draw the ROC, I can say, for this, first of all, this can be rewritten as 1 by 2 whole power n into u of n, minus this one can be written as 5 power n into u of minus n minus 1. So for this, the first one is the region of convergence mod z should be greater than 1 by 2 or 0.5. The second one is mod z should be less than 5. Now if you are drawing the ROC for these two functions, how will you draw the ROC? Let me draw. The ROC is going to be, so I will have to consider first circle at 0.5 and the second circle at 5. Correct, no, sir? Now, from this, what we can conclude? The conclusion is going to be the first one 0.5. The first one is lies at 0.5. Second one is lies at 5. The common ROC for all these people, for both of these people is going to be this one. It means mod z lies between the region of convergence for this function is exists between 0.5 to 5. Now the question is whether it is stable or not. For that you have to cross check whether the unity circle comes under this region or not. If you are observing, yes, it will come because 1 is lies between 0.1 to 5. So unity circle will lie somewhere around this, between these two. So the conclusion is from this, since Under ROC, we will have unity circle 1 under ROC. So the system will be stable. Finish. Directly what you can conclude, the given system is going to be a stable system. So whenever we are talking about region of convergence, it is very important to observe, stability and ROC. It is very important to observe whether the unity circle lies inside the ROC or not. After that, from there you can easily conclude that yes, based on the region of convergence, you can come to the conclusion whether the given system will be a stable system or not. Okay. Hope you will not forget these things hereafter. You must register these things in your mind because these things are a little bit important things. Okay, fine, sir. Next, let us see some of the properties of Z transform. We will see one by one. As usual, we will be starting from keep the heading, first one. So I have given all important things about ROC, region of convergence. Hopefully, you will not miss any of the points. Okay, fine, sir. So let's continue from here. The first property, keep that in, we are going to discuss about properties of Z transform. Properties of Z transform. So whenever we are observing properties, it is similar to the previous things. Already we have discussed about the properties of Fourier series. Then we discussed about the properties of continuous time Fourier transform. Then we discussed about the properties of discrete time Fourier transform. Now we are discussing about the properties of what? Now we are discussing about the properties of Z transform. The first property, as usual, the standard one is linearity. This is the first one we are discussing in R transform. Same thing, sir. There is no big difference. The first one, suppose, let us assume I am having a signal x1 of n. Its correspondent transform is going to be x1 of z. If I am having one more signal, let us take x2 of n. Its correspondent z transform is going to be x2 of z. Now, what I am going to do is, if you are observing, if you are adding these two response on the output side, we will find the total response because of x1 of n plus x2 of n is x1 of z plus x2 of z directly. First, individually we were passed with these two signals. Now what we are going to do is, we are going to accumulate them, that I am going to club them. Instead of passing these two signals separately, if we are clubbing these two signals on the input side itself, then what will be the resultant output? The resultant output is going to be simply x1 of z plus x2 of z only. So the conclusion what we are going to make here is, whether you are passing the signal separately, after that you are adding it, or you are clubbing them on the input side itself, then you are observing the output side. The both cases will going to give the same result. Just observe the difference. What I am doing, first case we are passing the signal separately. Then we are cumulating the output. That is case number 1. Whereas in the second case, we are cumulating. We are adding the input signal on the input side itself. Then we are passing it to the output side. In both of these cases, we are getting same result. That is called linearity. So this is the basically this property is called additivity principle. This is what we are calling it as additivity. Okay. Someone asked how to check causality. Yes, Kalimta, I will tell you. I will come to that point. Don't worry. We will discuss about it. So let me complete this, then I will talk about it. Okay. Let's continue. Listen. The thing is, the second property. We know now. Hope you all understand what is the meaning of linearity. The another most important property is time shifting property. Sir, what is the meaning of time shifting? The thing is, suppose first keep that in. Time shifting. The property name is time shifting property. So while discussing about time shifting property, let us assume I have a signal x of n. Its correspondent Z transform is going to be x of z. First thing. Shifting means your signal will be shifted by an amount of plus or minus n naught. If it will be shifted by an amount of plus or minus n naught, then how should I represent it? Let us see. Suppose if your signal will be shifted by an amount of plus n naught, then its correspondent Z transform is going to be z power plus n naught into x of z. Okay, this is the correspondent transform. Suppose if I am having x of n minus n naught, then its correspondent Z transform is going to be Z power minus n naught into x of Z. So here, what one thing you must understand here is, this thing is just in place of e power j omega, we are putting Z. That's it. Nothing else beyond this. If you are observing the discrete sequence, if you are comparing it with the discrete time Fourier transform, there we are using e power j omega. But here, just instead of using e power j omega, we are using Z. That's it. There is no big difference. Okay. So that is how we are applying the shifting property in time domain. Of course, it is very important. You must keep it in your mind. How we are applying shifting property. The another most important property is scaling property. That is often being repeated in the exam also. See, shifting property, it is one of the most important property while solving the problems. Because most of the time questions will be framed. You can observe that if you are solving some 20 questions from Z transform, at least minimum 10 to 15 questions by using this property only questions will be framed. There will be a shifting in the signal. Your signal will be shifted by certain amount on Z transform. So you have to be remember this property, very important. Keep that in. The next one is time scaling property. The another most important property is time scaling property. So when we are discussing about time scaling, I will show you what will happen if it is scaled by certain amount. So whenever we are discussing about time scaling property, whenever it is given, it is very important to observe how it will be represented. Let me show you. For an example, what we know is if I have a signal x of n, its correspondent Z transform can be simply written as x of Z. Okay. Suppose if it is scaled, if I am scaling this, remember, if I am scaling this by a certain version, usually the scaling will be done like this. How the scaling will be done? For an example, if it is scaled by a version of a, n times if it is scaled here, then in Z transform, what we have to do is, in the power same times of value will be raised. X of Z power a will become the resultant answer for this type of scaling. Just cross check how I am doing. Here it is in the denominator, because we know in scaling always in the time domain if it is in multiplication, in frequency domain if it is in division. In time domain if it is in division, then in the frequency domain it will be in multiplication. So these two people are always being changed each other. So you must remember this. And one more important thing what they will ask now in the examination. For x of 1, they will give correspondent region of convergence. They will define a certain value for region of a certain region of convergence will be given. Now the question is, what is the region of convergence of x of n by a? If this is the question, ROC will be given for the first one. The region of convergence, for an example, if I am taking the region of convergence for x of n is capital X, or you can choose some other variables to avoid the confusion. Let me take P. The region of convergence has been given for x of n is P. Then what will be the region of convergence for x of n by P? The correct answer for this function is the region of convergence. Very important property. This will become P power 1 by A. Do remember, this is most important thing. Directly asked in the one more question in any state government exams. So what we are concluding, sir? If I have a signal x of n and its correspondent region of convergence has been defined as P. If I have another signal that has been scaled by the version of 1 by A, then its correspondent region of convergence also will be scaled by a factor of 1 by A. That is all you have to remember whenever we are thinking about scaling property. Of course, a little bit important property only. So the another most important one is time reversal property. Keep that in. Next, we are going to discuss about time reversal property. So the another one, what we are going to discuss about now, time reversal property. So next we are going to discuss about time reversal property. So what is the meaning of time reversal? Just recollect, same thing. If I have a signal x of n, let us assume I have a signal x of n. Its correspondent Z transform is going to be x of Z. Now, if I am shifting this signal, if this signal will be shifted to minus n, sorry, if this signal is flipped, not shifted, it is flipped, negative side. We are reversing the sequence. If this signal is reversed or flipped, then its correspondent Z transform. This is going to be x of Z power minus 1. Understand, sir? This is how we are applying inverse property. This is also a little bit important property and you must remember this. Nothing else is there, just if you are changing the sign in time domain, of course in frequency domain also same thing will occur. That is all you have to remember. The another most important property is conjugation property. Next property is conjugation property. Let's see. So the another most important property is conjugate property. So from conjugation property, what we can say is, if I have a signal x of n, its correspondent Fourier, for example, if I have a signal x of n, its correspondent Z transform can be defined as x of Z. If I am taking conjugate for this signal, if you are taking conjugate for this signal, then its correspondent Z domain, there will be two conjugate. Your Z also will be in conjugate and the whole power also will be in conjugate. So twice, two times of conjugate you will have to consider. So you must remember, sir, these all are very, very important properties. The another most important property is differentiation in Z domain. This is one of the most important property. So at least, of course, you have to remember. And one more thing, when we are discussing about conjugation property, now, if they are saying that region of convergence, ROC of x of n, for the first one, if the ROC is defined as P, then for the second one also, your ROC will be defined as P only. ROC will not change because of taking conjugation for the signal. Okay, so these things you must remember. Similarly, if you are discussing about the another important things, previously I was discussing about time reversal property now. So when we are taking it back again, time reversal property, please go back. For example, for the time reversal property, when I was discussing about x of n, its correspondent region of convergence, I was defining it as x of z. If we are considering x of minus n, then its correspondent Z transform is going to be Z power minus 1. If it is given that its correspondent ROC is going to be P, ROC is definite, that is P, then what will be the ROC for the second case? The second case ROC will become 1 by P. These are a little bit important thing. You must carefully observe these things. So you should not miss at any cost. But time scaling I have already given. So when we are applying time reversal, now I have given. Then we were discussed about scaling property. So that is over. Conjugation I have given already. Now, if we are discussing about differentiation, I will tell you. Anyway, differentiation also will not affect ROC. Let us discuss about the another most important property, that is differentiation property. Keep that in. The next what we are going to discuss now is differentiation property. So the another most important zone is differentiation property. So while discussing about a differentiation property, what you must remember is, for an example, if I have a signal x of n, then its correspondent Z transform will be defined as x of z. Then what is the meaning of this differentiation? See, I am applying specifically this will be asked in Z domain. Differentiation will be possible in Z domain, in frequency domain. So the next what they will do is, if they are differentiating a signal in frequency domain, then what will be the correspondent changes in time domain? That is the question. Here it will become n times of x of n. Sir, you should not forget this. This is a little bit important formula, often being asked in the examination also. Let me write one more time also for your understanding, just for registering these things. If you will have n times of x of n, any formula, any things will be given. Some standard value will be given, along with that n will be given. Then what will be its correspondent Z transform? That is going to be minus Z times of d by dz into x of z. Hope you will not forget, because this is very, 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 very important formula. And of course, many of you have failed to observe, because when you are solving so many questions, suddenly when some property will be given, some equation, some sequence will be given like this: a power n into u of n into a power n into u of n will be given. What will be its correspondent Z transform? Definitely you all know, for a power n into u of n, you know the answer. This one can be written as 1 upon 1 minus a into z power minus 1. For this z transformation we know. But suddenly what you will not be thinking is, yes, if it is being multiplied by n, we will have to what? After writing this answer, we will have to write down minus z into d by dz into 1 upon 1 minus a into z power minus 1. If you are doing the differentiation, after that it is multiplied by minus z, that will give you the final answer for n into a power n into u of n. This is what most of us are failed to observe. But it is a little bit very important. Of course, you must taking care of this property. That is what I am saying. This property is a little bit most important property. So hereafter, whenever any sequence will be present in the examination, along with the n, if something will be given, if some function will be given while solving the questions also, if something will be given with the n, immediately your mind will be goes to okay, differentiation property. First derive the transform for the given function. After that, if it is multiplied by n, then differentiate minus z into d by dz into x of z. That's it. Okay. Next. So the another most one is convolution property. Next, what we are going to do now? Let us discuss about the another most important one, that is convolution property. The next one is convolution property. So when we are discussing about convolution property, how should we define? Convolution means, as we saw already in our Z transform, specifically we are having a certain signal. See, our input signal has been standardly defined as x of n. Its correspondent transform can be defined as it is going to be x of z. Next, we will have LTI system. Most of the time, that is what will be given even in the exam also, h of n. LTI system. Its correspondent Z transform is going to be h of z. If these two signals are involved in convolution, x of n, it is involved in convolution with the h of n. Sir, already someone asked the difference. What is the difference between convolution and multiplication? For this, in the comment section itself, I have given the answer in the first class or second class. Please go through the comments. When we have started the sequential system, in the second video or first video in the comment section, I have given the detailed explanation, the difference between the convolution and the multiplication. You can just have a look. So you see, if two signals are involved in convolution, then its correspondent multiplication is going to be, what will happen, sir? In frequency domain, its correspondent Z transform will get simply multiplied. That's it. This is another most important property. Now I will tell you one more thing what you must observe when we are discussing about the convolution property. And before that, we were discussed about the differentiation property now. In differentiation property, another most thing what you have to observe is region of convergence. I will tell you, please go back there. Because of the differentiation, for example, I have a signal x of n. Its correspondent domain is x of z, and let us say the ROC region of convergence has been defined as P, random value. Then if I have n times of x of n, I know for this we will have to differentiate. Minus z into d by dz into x of z is what I should consider. But because of this, whether your region of convergence will change or not? No. Your region of convergence will be remain same. So what is the conclusion? Differentiation property does not affect the region of convergence. One more question. Differentiation property does not affect the region of convergence. You must remember this. The another one is convolution property. Let us say x of n, its correspondent convolution is P. And for h of n, its correspondent convolution is Q. It has been given. The region will be given. Then what will be this is the ROC, region of convergence. ROC for the first one, ROC for the second one. Then what will be the ROC of these two? Always remember, convolution means a area which is lies under the covered portion. See, we are during the convolution, two signals will be mixed each other. That is overlapping each other. So we will be considering only overlapped area. Overlapped area means the common zone between the two signals. So its correspondent ROC also we consider as, you have to take P intersection common zone with the Q. That is the resultant ROC when two signals are involved in convolution. Of course, this is also one of the another most important property that you must observe. Okay, sir. So region of convergence is very important because you are preparing for, especially in state government exams, these type of 1 mark questions will be directly taken. For x of n, corresponding ROC will be given. For h of n, corresponding ROC will be given. If two signals are involved in convolution, then the correspondent region of convergence is going to be the common zone, P intersection with the Q. Hope you understand. These things you must keep it in your mind. Let us enter into the another most important area, that is called accumulation property. Let us go ahead. As I already told you, this is also one of the most important area. Often questions will be framed. I have given the accumulation property for discrete time Fourier transform also. Hope you remember that. In the same way, here also nothing. Just in place of e power j omega, here we will be getting z. Just recollect your notes once, it is there. So the other most important property is accumulation property. The next one is accumulation property. Let us discuss about accumulation property. Sir, what is the meaning of this accumulation property? Accumulation means there is summation. For an example, see, if I have a signal x of n, its correspondent z transform has been defined as x of z. Now, if what we are going to do here is, let us assume this x of n is a sequence and it is running from minus infinity to a certain point. So let us take summation. This n is running from minus infinity to a certain point p. Let us take randomly. Then what can be the expected transformation in this? The resultant is going to be, as usual, whenever we are doing this, whenever a summation will be separately allowed, then its correspondent z domain is going to be 1 upon 1 minus z power minus 1 into x of z. Sir, this is another most important property that is also repeatedly asked in the examination. Actually, what will happen now? I will tell you what is the formula to obtain the x of z from x of n. The general formula what you will be writing is n equal to minus infinity to plus infinity, and you will be writing x of n into z power minus 1. This is the standard one that we are following till now. Now what they did is, in the x of n itself, they changed the signal like this from here to here. So what I have to rewrite this function is, now double summation will come, n equal to minus infinity to plus infinity, one person will come. The another person is again one more summation will come, n equal to minus infinity to a certain point, along with this x of n will come into z power minus n. In this situation, if you are not properly remembering this property, that time automatically you will be confusing. Because while observing here itself, you may not be able to predict the correct answer. So what I would like to conclude here is, see, one thing what we have to understand here is, whenever this type of function will be given, okay, directly consider a factor 1 upon 1 minus z power minus 1. Along with that, now you can consider n equal to minus infinity to plus infinity, whatever the sequence that is given for x of n. It is a signal. Some signal will be given. Here we are taking general value. But for x of n, they will give something. Substitute that value with the z power minus n. Now transform its correspondent z transform is going to be x of z. So that x of z value into 1 by 1 minus z power minus 1. As most of you are preparing for AE, JE, state government exams, so this question will be directly asked. Like this property will be directly asked in 1 mark question. So it is very important to know the detailed explanation for accumulation property. Just not a detailed explanation, the detailed version. How should I convert this from here to here? Same thing I have defined in discrete domain Fourier transform also. 1 upon 1 minus e power minus j omega is what we got there also. Into x of j omega or x of e power j omega is what I was defining there. Correct, no sir? So all you have to do is, see, just the conversion is, in place of e power j omega, omega or ohm, both will be representing the frequency only. So either you can write it in this way or you can write it in this way. Both will give you the simple conclusion or simple only one answer or only one solution. That is what you have to remember. Let's enter into the another most important zone, that is multiplication in time domain. What we observed here is, we saw if two signals are involved in convolution in time domain itself, how can we transfer it into frequency domain? That is what we saw. Suppose if these things are happening in the opposite way. Opposite means, for an example, I have a signal x1 of n. and its correspondent transform we can define it as x1 of z. I have one more signal x2 of n. Its correspondent transform has been defined as x2 of z. Now what is the problem here is, suppose if these two signals, it is given that we are multiplying these two signals, x1 of n is involved in multiplication with the x2 of n. Then what can be the expected correspondent representation? How if two signals are involved in multiplication in time domain, definitely its correspondent mixed in frequency domain, they will be in convolution. In one domain, if they are in multiplication, the opposite domain, definitely they must be involved in convolution. But in frequency domain, that too in Z transform, how can we represent it in convolution? That is, what will be the standard format to represent the given signal, and what will be the resultant ROC, region of convergence? That is also very important. Let's see. That is very simple. Here, dummy variable will be introduced along with this, and the answer is going to be 1 by 2 pi operator j will come along with it. As I told you, we are in what? Z domain. In Z domain, there will be a circle. Always you will be considering the circle to define the stability or causality of the system, anti-causal system, anything. Everything will be concluded only with the help of circles only, as we observed. And I have to introduce some dummy variables here. So let me consider x1 of p, as usual. I am using some standard dummy variables. x1 of p into x2 of z by p. The dummy variable will play a role here. Into, so we will have to consider d. So we are differentiating this function with respect to p. Later on it will be transformed. So dp, and of course there will be one more p will come here. That's it, sir. So just remember the properties, that is enough. Okay, you don't need to remember any other things beyond this. Just to remember the property, because they will ask this type of question directly. They can't take any questions, numerical questions from this area. One more thing, what you have to observe is, for an example, the first one ROC is A, second one ROC is B, the region of convergence for the second one. First one is A, the second one is B. Since they are involved in convolution, it doesn't matter whether the convolution is happening time domain or frequency domain. Convolution means overlapping area, common zone, intersection area. So I will have to consider only the area which will be in intersection, which is common for both of these people. So the resultant ROC for both of this, whether the convolution is in time domain or frequency domain, it doesn't matter. Common ROC is going to be A intersection B will be your convoluted value. So you must remember these things also, a little bit important, sir. Okay. Hope you will not forget these things hereafter. Next. So we have understood the accumulation property. See, one more thing what I left is for accumulation property, region of convergence. One thing. Go back there. Sorry. We were discussed about accumulation property. What will be the region of convergence for this? For an example, x of n, x of z is given. Its correspondent region of convergence, let us say, it is given defined as A. Its correspondent region of convergence is defined as A. Then what can be the expected region of convergence for the second case? That is the most important one. The region of convergence will be defined for this case. You will have to take same A, and along with it you will have to consider the common intersection area where the value of mod z should be greater than A. Are you getting me? The value of mod z should be greater than A. Greater than A, whatever the common area that you are having, from there you should consider A. Just write down this formula. Remember this. That is a little bit important. Region of convergence property for accumulated signals. So whenever accumulation property will be given, you must remember the region of convergence also. It is very rare. At the same time, we cannot skip this. You should remember this. The another most important property is first difference property. From first difference property also, there are n number of questions has been framed. You can observe in any state, many state government exams and central gate everywhere. You can observe from the first difference property questions has been framed. Let me write down the property first. So the first difference property, how should we define, sir? First difference means, suppose I have a signal x of n. Its correspondent z transform can be defined as x of z. Then if I have a signal x of n minus n naught, Then its correspondent Z transform can be defined as Z power minus n naught into x of Z. If I have a signal x of n minus 1, then its correspondent Z transform will be defined as Z power minus 1 into x of Z. Now first difference means, I have also defined this first difference when I was discussing about discrete time Fourier transform. Here also the first difference means just we will have to find the difference between xn and the x of n minus 1. Its correspondent transform is going to be, for x of n this can be written as x of z, for x of n minus 1 this can be written as z power minus 1 into x of z. From this you can take x of z outside, so this can be written as x of z into 1 minus z power minus 1. This is the property of first difference. Of course, you have to remember this. That is another most important property of Z transform. Hope you will not forget any of these things that we have discussed so far. So whenever Z transform will be coming, no? So don't forget to apply the things. First one is, if it is questions will be framed from region of convergence. At starting, I have given 4-5 sequence how to define that. Only remember those things. Repeatedly revise. And if you are observing the new question, that will automatically help you to get the answer from there. And the another most important area is, in Z transform, the one more thing what you must remember is inverse Z transform. As I told you, we will not be using the standard formula that I have given. We are not using that formula because I told you, if you are trying to figure out the inverse Z transform with the standard formula, it will not give you the answer easily. It will be a little bit complicated one, a lengthy process. It may not be help you to figure out the answer within a given certain time period when you are involving in the exam. What I have to do, sir? You can go ahead with this. There are standard methods. The first one, partial fraction, we are often using. What are the methods that is studied? While applying partial fraction, you have studied something in Laplace. Same thing you can apply here. And the second thing is long division method. That is the other most method. Somewhere it will be helpful for you. These two will be often using. The long division method and the partial fraction. There will be one more method that is called a residual method that can also be used, but I am suggesting you to go ahead with only these two. Don't apply anything beyond this. First learn detailed explanations how to apply partial fraction. If you understand these things in Laplace transform, then in Z transform that will be simply help you to figure out the answer. Only some small variations will be there, the minute variations. Procedures and all remain same. But in Z transform, whenever we are applying partial fraction, it is very important. For an example, let us assume I have a signal Z square divided by Z minus A. Now the question is, we will have to find out the Z transform. Let us assume, one second, wait. Z divided by, let us assume we have Z minus A into Z minus B. If a signal will be given like that, we will have to take inverse Z transform for this. How should I do this, sir? While applying inverse Z transform, the important thing what you must carefully observe is inverse Z transform. Let us assume x of Z equal to Z upon Z minus A into Z minus B. Sir, before applying partial fraction directly, one thing what you must observe is, while taking inverse Z transform, suppose if I have a function Z by Z minus A, then what will be the Z inverse Z transform for this? We can directly write this is A power n into U of n. Assume it is right-sided signal. Mod of Z is greater than A. Suppose if mod of Z is less than A, then you will be directly writing your answer is, for left hand side sequence, this can be written as minus A power n into U of minus n minus 1. That will be your answer. Yeah, you are correct. Absolutely, you are correct. But what you must observe here, in order to apply inverse Z transform, in the numerator we must consider one Z, and in the denominator we need one Z. Without keeping this Z, it is not possible for you to take inverse Z transform. So it is very important to keep one Z term. We have to hide before applying partial fraction. Always keep this C. If Z is available in the numerator, bring that Z to the left hand side. Just hide it for some time. Only for remaining term you should take partial fraction. Always remember, only one Z. Sir, if I have Z power 3 in the numerator, no problem. Z power 4, no problem. If I don't have Z, then also, see, suppose if you don't have Z here, then what I have to do, sir? Multiply and divide your numerator by Z and divide it by Z. Then bring one Z from right hand side to left hand side. After that, for the remaining function, you can apply partial fraction. Understand? Hope you understand what I am trying to conclude here. So it is very important to bring one Z term before applying partial fraction, such that now see that after now I have Z here, I brought it here. Now this is the resultant. Now only apply partial fraction. This for the above function you have to apply partial function b by Z minus b. Okay. So after finding, let us assume a equal to 1 and b equal to 2. Just let us take some values such that this can be written as a by, it is easy for us to calculate unnecessarily, otherwise we have to waste the time. Now calculate the value of, now apply standard partial fraction, find the value of a. How will you do it, sir? The value of a is equal to, take the overall transfer function, cancel the value of z minus 1, remove z minus 1 from here because that is the coefficient of a. Then substitute z equal to 1 here, the value of b equal to 2, so 1 minus 2 will become minus 1. Similarly, find the value of b. If you are putting z equal to 2 here, 2 minus 1 will become 1. So b equal to 1. After finding that, you can rewrite this 1 by z minus 1 plus 1 by, sorry, this is minus 1 now. This is 1 by z minus 2. Finish, sir. Then pass this z. Now this is equal to x of z by z. Now pass this z to the right hand side such that this function can be rewritten as minus z by z minus 1 plus z by z minus 2. Now based on whether they are asking left sided sequence or right sided sequence, based on the options that will be available, you can convert this. Keep minus outside. If it is the right sided sequence, then the answer will become 1 whole power n into u of n. This is going to be 2 power n into u of n. Suppose the first one is right sided, suppose, or in the option it is given, first one is right sided. 1 second. The first one is right sided. Right sided means, and the second one is left sided, minus 2 power n into u of minus n minus 1. Like that, you can write down the final answer. But while applying partial fraction, you have to carefully remember that you must hide one z on the left hand side. Otherwise, definitely it may lead to lose your score. Okay, sir. That's it. So I have completed all the required things. Apart from that, some basic things I have to conclude, that like what is the meaning of causality, what is the meaning of causal signals, anti-causal signals, and the non-causal signal. How to define these things we will cover in the next class along with some other things. Then we will be completing sampling theorem also in the next class. Because I have already crossed your time, let us finish sampling theorem also in next class. After finishing this, we will go ahead with the basic signals and the system. Okay. Till then, if you have any other things to discuss, you can also drop your things in the comment section directly. Let's meet in the next class soon. Thank you all.